Okay, in this video we're going to cover section 11.4, which is the square root and cube functions. So we'll start with the square root function. Problem 28, the basic square root function is the function f of x equal the square root of x. We're going to sketch the graph of the square root function and then state the domain and the range. So I've set up a table of numbers on the side here, and of course I can't let x be a negative. I'm not doing anything with I or imaginary numbers. X can be 0, that's fine. Square root of 0 is 0, so here's 0, 0 on the graph. If x is 1, square root of 1 is 1, so here's 1, 1 on the graph. Try to select nice numbers that you can compute the square root of off the top of your head here. So like if x is 4, we know the square root of 4 is 2, right? So here'd be 4, 2 on the graph. The next nice number to use would be 9. The square root of 9 is 3, okay? Here's 9, 3 on the graph. And so the curve is going to be starting at the origin and then curling upward and outward towards the right into quadrant 1. Okay, and actually this graph, this curve, would take on the shape of a half of a parabola, okay? And the domain of the function would be all non-negative numbers, right? We said that we don't want x to be a negative. We're not doing anything with imaginary numbers here. So 0 to infinity. And of course, anything coming out of the square root calculation is never going to be a negative. The range of the function, therefore, would be the same interval, 0 to infinity. Problem 29, we're going to graph the function f of x equal the square root of x plus 2 plus 3 using a table of numbers and then state the domain and range. Okay, so I've got my table set up here. Now, the shape of this graph is going to be very similar to what we saw up here, a half of a parabola. Of course, I can't have a complete parabola facing towards the left or the right, because otherwise it would fail the vertical line test and not be a function. So I know I should know right away that I'm going to be graphing something that's going to take on a similar shape here. If we let x be negative 2, that'll give us our start point here. So negative 2 plus 2 is 0. The square root of 0 is 0. Plus 3 is 3. Okay, so here's negative 2, 3 on the graph. If x is negative 1, negative 1 plus 2 is 1. Square root of 1 is 1. Plus 3 is 4. So here's negative 1, 4 on the graph. And I would also add that, try to select nice numbers here. Can do the calculations without a calculator. Like if x is 2, we know the square root of 4 is 2. We don't need a calculator, right? So 2 plus 3 is 5. Here's 2, 5 on the graph. The next nice number to use would be 7, because then we'd have the square root of 9, which is 3. Plus 3 is 6. Okay, so here's 7, 6 on the graph. And this curve would look very similar to what we see here. Okay, so it'd be only starting at negative 2, 3, and then curling upward and outward towards the right. The domain, anything that is negative 2 or bigger is going to be okay to use. And then the range from the picture here, anything that is 3 or bigger on the y-axis is going to put us on the graph. Okay, so then part B, recall the topic of shifting. We looked at that in the last section. In general, we can sketch the graph of a function, f of x, which is going to be the form x minus h squared plus k by shifting the graph of f of x h units in the horizontal direction and k units in the vertical direction. Okay, we're going to state the horizontal and or vertical shifts that would be applied to the square root function to get the graph of this guy here. Okay, so what I was talking about right here is, applies to a parabola, but really, I can extend this to the idea of other functions, for what we have here, x minus negative 2, that'd be the same as x plus 2. H would be negative 2 then. And k would be 3. So we see in this graph that if we start with the original, we go to the left 2 and then up 3. Well, what's causing the graph to go to the left 2 would be the plus 2. What's causing it to go up 3 would be the plus 3. Okay, so I could kind of use that idea of shifting, that we talked about in the last section there. Here's another kind of function that we'll need to know is the cube function. So problem 30, the basic cube function is represented by f of x equal the x cubed. Sketch the graph of the cube function and then state the domain and the range. Okay, so I've got my table set up here and I'm just selecting values. If x is 0, 0 cubed is 0. Here's 0, 0 on the graph. If x is 1, 1 cubed is 1, so here'd be 1, 1 on the graph. If x is negative 1, negative 1 cubed is negative 1, so here's negative 1, negative 1 on the graph. If x is 2, 2 cubed is 8. Here's 2, 8 on the graph. And we'll just take one more. If x is negative 2 cubed is negative 8. So here's negative 2, negative 8 on the graph. The graph is going to be shooting off in different directions here into quadrant 1 and quadrant 3, and there's going to be a little squiggle in the graph at the center. That's kind of a feature of the cube function. The domain is all real numbers. I can cube any number I want. Okay. The range would also be all real numbers. When you cube a number, you're just going to get another number in return. It could be a negative. Unlike when you square a number, you'll never get a negative. That's different when you cube a number. So yeah, this would be the most basic cube function then that we see. Problem 31, we're going to graph the function f of x equal x minus 2 cubed minus 4 using a table of numbers and then state the domain and the range. Okay, so the first thing that I'd want to know is, I'm going to be graphing a curve that very much looks like what I see here. It's going to be relocated though. Now, to get the center, I would just take a look at the expression that I'm cubing and set that equal to 0. X minus 2 equals 0 means that x is 2. So it would make the most sense to be using values that are around 2 when I set up my table here. Now, of course, I can let x be anything I want, but I don't want to be selecting numbers that are way out yonder, away from the interesting part of the graph. If x is 2, 2 minus 2 is 0, 0 cubed is 0, minus 4 is negative 4. Okay, so here's 2, negative 4 on the graph. And I usually just take two numbers that would be to the left of that center spot and then two numbers that would be to the right. So two numbers that are to the left of 2 would be 0 and 1. Two numbers that are to the right of 2 would be 3 and 4. If x is 0, 0 minus 2 is negative 2. Negative 2 cubed is negative 8. Minus 4 is negative 12. Okay, so here's 0 and negative 12 on the graph. If x is 1, 1 minus 2 is negative 1. Negative 1 cubed is negative 1. Minus 4 is negative 5. Here's negative 1, negative 5 on the graph. 1, negative 5 on the graph. And then if x is 3, 3 minus 2 is 1. 1 cubed is 1. Minus 4 is negative 3. Here's 3, negative 3 on the graph. And if x is 4, 4 minus 2 is 2. 2 cubed is 8. Minus 4 is 4. Okay, so here's 4, 4 on the graph. And using these 5 points, I can draw in a curve that's going to take on the shape of this one up here. There's going to be a little squiggle in the center there, and then you're going to be shooting off in different directions. The domain and the range of any cube function are always going to be all real numbers. Okay, and we can see that from the picture here in this problem. Part B, recall the topic of shifting presented earlier in the last section. Okay, in general, we can sketch the graph of a function, the square function there, by shifting the graph of f of x by h units in the horizontal direction and k units in the vertical direction. Okay, so state the horizontal and or vertical shifts that are applied to the graph of y equal x cubed to get the graph of what we just drew here, f of x equal x minus 2 cubed minus 4. So it looks like if we start with the original, we had to go 2 units to the right and then 4 units down. The -2 is what's causing the graph to go to the right 2 units. The -4 would be what's causing it to go down 4 units. Okay, so really I'm just relocating this basic function here by moving all the points to the right 2 and then down 4. Okay, problem 32, write an equation for the graph shown. So I know I'm going to be doing something with the cube function. Okay, I can see the kind of the shape that I'm working with here, which is like these other two. I'll call the function f of x, and this center point here is -1, 6. Okay, so my h value would be -1, and my k value would be 6. Now in the formula, I've got x minus -1, so that'd be x plus 1, and of course I'm cubing, not squaring, and then k is 6, so it'd be a plus 6 at the end. Okay, and it's like we started with this graph here, and we just simply went to the left 1 and up 6 with all the points, and that'll put us in this spot. Okay. You'll do a lot more with shifting and relocating a curve in college algebra. They call it transformations. Transformations are a really handy technique when it comes to graphing. More on that in the next class. But so anyway, we'll stop right here. The homework is on page 901.